The floor is broken.
I opened up like B1 and then I was doing B2. And I felt slightly, but I was
Okay, let's take the
I did
attention
all
first.
wrong. I was laughing so.
For Jonathan, I know.
No, maybe. Rose. I don't have single line. You don't have?
No, you don't feel
No, what the fuck?
so intense match between me and
Leo
Sam.
and Jeanette.
Jeanette.
Same as last time. You're doing drying your hands. Leo extra.
What? Puta, miramos gago.
Number 12.
What?
24 and 32.
68 is another good.
Sir, learn our names.
Rivet.
What? I'm absent. I said, fuck, why absent that?
24
Fuck,
and
why?
32.
Fuck, why? Yeah, sir, 21.
32. 32, yeah. 32. Not 32. And 22.
Yeah, 32.
Yes. And 22.
Should be. Okay.
Oh, fine. My bad.
And number 9.
I got no glasses. I can't see properly.
Right, okay,
I
so
will give it.
let's
What's
start.
happening?
Can you take out the worksheet from yesterday? And we'll do a quick summary on all the reactions, and then I will try one question and move on to important organic substances. Okay. So let me go back to your notebook here first. Right, on a new page on the notebook, okay, yeah, I want you to draw down the summary of organic reactions. So summary of organic reactions or conversions. Right, okay. We have in here, at the center of the stage, we have alkene. So alkene, they are very important. They have C double bonds. So alkenes can be converted into a number of other organic compounds, such as alcohols or haloalkanes. So haloalkanes. So write down their like the formula here: ROH for alcohol and RX for haloalkane. Where X can be anything from Cl to Bl or to I. So these are haloalkanes. Alkenes, they can also be converted back into alkane. Let's put alkane on the right. So alkanes by addition reaction with hydrogen. And then the alcohol, okay, they are also pretty special as they can be oxidized depending on their class onto aldehyde or ketone. And finally, aldehyde can be further oxidized into carboxylic acid. So you see, this is like a web, okay, it extends outward, okay. We have carboxylic acids. Right, so going this way, okay, can anyone tell me what is the name of the reaction or maybe the reactants required from alkene to alkane? What do we need to convert alkenes into alkanes? We need to add hydrogen. What is the catalyst? Platinum. So put this down. You can add hydrogen, and the catalyst is platinum. And this reaction, if you really want to describe it with a name, you call it hydrogenation, which is a type of addition. And you can also add other things onto alkenes. Okay, for example, you can add halogen X2 onto haloalkanes. Okay, or you can also add HX, hydrogen halide, onto alkenes to form the haloalkane. So the difference between adding X2 and HX is that one adds just one X across the double bond. The other adds two X's. Right. Okay. Yeah, and then we have for alkenes, they can, for DSC, we will only be converting the alcohol into alkene. So sorry, the other way. Yeah, can you point this the other way, my bad. And what is that reagent needed? There are two things that we can use to turn an alcohol into an alkene.
Concentrated sulfuric acid.
Concentrated sulfuric acid. Okay. Equally suitable for this reaction would be aluminum oxide. Yeah, aluminum oxide. So they are said to be dehydrating agent. So the reaction here, you can call this dehydration. Right. Yeah. Right. Maybe you can talk about that later in the break. Okay. So you have addition, reaction. So there's a subtle difference between the addition with X2 and the addition with HX. We call this halogenation because you're really adding two X's across the double bond. And this we call it hydrohalogenation because we are not just adding halogen but also an H. So hydrohalogenation. And do you remember how we convert from alcohol? I convert alcohol into haloalkane and haloalkane back into alcohol. You see this go both ways, right? We talked about this yesterday. One is the
PCO.
or pH3. Yeah, pH3. Which way do we use pH3? Top or bottom? Top, yeah, because that's when we want to replace OH with X, so we add pH3. So just as suitable is another compound, HX. Yeah, so this is an alternative method. Just like we have two alternative dehydrating agents here, we also have two alternative halogenating agents. What about the reverse reaction? OH minus aqueous. Make sure you write down OH minus in aqueous condition. Okay, aqueous. Yeah, and let's move on to the left-hand side of the flow chart here. We'll be using this to answer one more question, or maybe two more questions on the worksheet, and then we'll move on to the important organic chemical. Which class of alcohol can be oxidized to aldehyde and subsequently to carboxylic acid?
First.
Primary, yeah. So we will write down oxidation here. So this is by using which oxidizing agent? What is an example of oxidizing agent? Acidified dichromate, yeah. If you don't feel it right in the name, make sure you write K2Cl07/H. This is very important. Going backward, we call this reduction. Okay, we will need reducing agent. There are two reducing agents suitable. What are they? One can be used with water, one can only be used with dry ether. Which is it? Which is the one that can be used with only dry ether?
Lithium LiAl.
Oh, yeah, okay. If I were you, I would also write out the formula instead of stating the name. The name is lithium aluminum hydride. Very, very long word. You don't have time to write it all in the exam. Just write down the formula. LiLH4 in dry ether. So you will need to write it as two separate steps. Okay, so LiLH4, dry ether. The second step is to add H plus in aqueous condition. Or you can use, what is the alternative? N4, yes, this can be used in aqueous condition. So that means you either draw these two arrows in here, or you draw these single arrow in here. So either, okay, you cannot put, so by that I mean, let me be clear. You see this arrow pointing this way. So when asked what is needed to convert carboxylic acid back into alcohol, can you move this arrow out of this position? Sorry, this arrow should go from here all the way to there. Sorry. Yeah. So if you want to describe one of these red crosses here in one step, it will be LiAlH4, it will be NADH4. So you see this has only one step. So you see just step 1 here. But if you see 2 arrows going from carboxylic acid to alcohol, then you know LiAlH4 is used, because in step 1, okay, you write down LiAlH4 in dry ether. In step 2, you will write H+. Okay, yeah, but you can say these 2 steps is equivalent to the single step in here. So depending on how many arrows you see between the alcohol and carboxylic acid, you will either write LiAlH4 or NADH4. Let me give you an example. When you have CH3COOH in the exam, and they are giving you 2 arrows, and then at the end you have CH3CH2OH. Compared to when you have CH3COH, a single arrow, becoming CH3CH2OH, when you ask what these things are, what should we put in here? Is it LiAlH4 or NADH4 for the first one? LiAlH4. But you see together, they do the same thing. Yes, this is it. Okay, so can you put down the first unknown? Maybe let's not call it question mark. Let's call this X, Y, and Z. X is equal to LiAlH4 dry ether. Y is equal to H plus aqueous. Z is equal to NADH4 aqueous. In other words, X and Y is equivalent to Z. Okay, so this is equivalent to Z. Okay? Right. Now we have this other reaction here, stretching this way. We have oxidizing agent turning alcohol, secondary alcohol into ketone, and a reducing agent turning it back to alcohol. Now finally, we have also the reaction known as esterification. So which 2 chemicals you see on this flow chart, when combined, can form an ester? Carboxylic acid and alcohol. What is the catalyst required? Sulfuric acid. Okay, can you draw, maybe using a different color pen? These 2 chemicals, they can join, okay, in a reaction known as esterification. So esterification, with the use of the catalyst concentrated sulfuric acid to form another compound known as ester. Okay? Yeah, and I think that's pretty much it. Okay, yeah. So now I will show you this on the screen, and you can take out your worksheet now. We'll be using this flow chart to complete 2 more questions. Okay, and then we move on to what is that? The important organic chemical. Okay, I have it open it here. Where is the, okay, this one. Can you turn to maybe, okay, this seems to be an interesting question here, 8, okay, 9A. Outline a synthetic route with no more than 3 steps, you see? Yeah, so in no more than 3 steps for each of the following conversions. So don't forget, what we should do as the first step is to identify the type of functional group present or the type of the molecules involved. So can anyone tell me what is the nature of this chemical here? Is it an alcohol?
No.
No, what is it then?
Alkene.
This is an alkene and also at the same time a haloalkane. Write this down. This is both an alkene and like a haloalkane. What about the product compound?
Which question?
The product compound. It's just a haloalkane.
Yeah.
Well, that means we need to eliminate the alkene functional group. The alkene has to become something else. Okay, if not, like we couldn't explain why the alkene functional group is gone. So now refer back to your flow chart. Okay, where's your flow chart here? There is only one way to get rid of the double bond. Okay, and that's by converting the alkene into an alkane through hydrogen and platinum. So let's get rid of the, let me copy this question over first. Just a moment. We have CH3. Okay, so let me show you them side by side. And then you can also write at the same time. So we have CH3, CH3, CH double bond, CH, CH2Br. If I were you, I would just take out the carbon, 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 and then the hydrogen, and then I'll connect them. C, 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 and then we have the Br here. And we have the double bond between the second and the third carbon. Ignore all hydrogens, okay? Only focus on what matters, the Br and the C, and perhaps the CC double bond, of course. And what about the target product? We will also draw it the same way. We have CH3, CH2, 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 Cl. Ignoring all the hydrogen, you get C, Cl. Okay. Well, first of all, we can get rid of the double bond first, and that's by hydrogenation. Okay, so you can write down your first step. Okay, so step 1, underline the instruction here with no more than 3 steps. Okay, so everything should be done in 3 steps. So maybe I'll put 3 arrows here. Okay, the conversion should be completed. Okay, by the end of these 3 steps. The first reaction is hydrogenation. What is the catalyst?
Platinum.
Platinum. Okay, remember where the hydrogen will go? Does it add itself anywhere on the molecule? No, but only across the CC double bond. Okay, so can you draw that for me? You have C, and Br, and then you have 2 H's added. Here, you can also draw it on top, facing the top. Doesn't matter, as long as it's at these 2 carbons, not any other carbon. Now, what? Okay, we can turn haloalkane into alcohol using which reaction? You see, we are now at the haloalkane. Let's look at where we can go from haloalkane. Haloalkane is here. In order to turn it into alcohol, what can we add? Hydroxide ion. Okay, and why do we want to turn it into hydroxide? You may ask. That's because, can you see that I didn't specify what X this is, right? So that means I can start from RCl. Let's just imagine that I start with RCl. I add OH minus into it, and it will turn into OH. Then I can, let's say I have a change of mind. I hate seeing RCl. I want to turn it into RBl. What I can do is, I first force the RCl to become an OH first, and then I use a pH3 with my desirable halogen. Let's say I want to change it to Br. Then I will first add OH minus to RCl, so that it's now OH, and then I add PBr3 into it, and now it's back at RBl. Do you get it? Okay, you can use this reaction over and over. Remember the roundabout analogy I said? This is like the roundabout. You can go through this cycle as many times as you like. If you don't like RCl, just switch the X into another one that you like. Maybe I or Br. Okay, so now let's do this. What should I add in here again? OH minus. Don't forget to put that aqueous. It has to be aqueous hydroxide. Okay, sodium hydroxide, for example. So what's the product?
CCCCOH.
Yes. Name.
Butane 1.
Butane 1O. Okay, so I'll write down the name of the other compound because that's not the main point of this exercise. So butane 1O. This is 1-bromobutane. And the top compound here is 1-bromobu2E. And I'll leave the last compound's name and also the conversion to get to the last compound to you. You have 20 seconds to figure out how we can convert this back into it. If you really can't remember, you can refer back to the notes. Yeah, and I also want you to name it. Okay. Okay, so what should we add in the last step?
PCO3.
PCl3, yes, PCl3. And that will turn it into it. What's the side product that we get when we add PCl3? Do you remember? It's an acid that is the brother of phosphoric acid. Phosphorus acid, what's the formula? What's the formula? H3PO3, H3PO3. So where do mentioned that somewhere like a while ago. Okay, yeah. So, but yeah, if you remember, that means I think it's somewhere in here. I forgot. Okay. But you remember, right? P. Okay, let me write that because just now I couldn't find it. Okay, write that as well. So ROH plus PCl3 will turn into RCl plus H3PO3. That's also when I said you need to balance this equation by putting a 3 here, right? Yeah, so I remember I said that, but for some reason I couldn't find it, don't know why. Okay, so, okay. Anyway, we are back at the final product. What do you name this product? Should be easy.
1-chlorobutane.
Yes, 1-chlorobutane. Okay. It's more important to get the order right. Once you get the order, you can get the punctuation right.
So
Okay.
you can go 1, 2, 3, 4. So you have to name it.
Yeah. So if you're thinking about counting it from the left, okay, that way wouldn't work because that will result in a larger number. Okay.
So can we write just like this in the DSC if they
Right. You need this pathway.
Yeah.
Yes, this is exactly what they want you to do. Okay, yeah.
Oh.
So you just have to suggest the reagent. Reagent meaning what you need to add. So this is the reagent. The conditions, if required. Usually condition will be heating, distillation, reflux. That kind of things are what we mean by conditions. So can you put down in here? Where is the reactant? You know, this is the reactant, right?
Yeah.
Yeah. So can you put down reactant? And in here, that's the product. What do you call anything that is in between? Intermediate. Yes, very good. So maybe draw, if you ran out of color, then just use dotted line maybe. So anything, everything I should say in between the reactant and product, we call them intermediates. And do you know why the DSC wants you to include no more than 3 steps in the exam? What is the difference between having 10 intermediates between the reactant and product and having maybe just 2 or 1 intermediate between the reactant and product? How do you think this will affect the yield of your product?
Like more pure.
There will be a higher yield when there are more or when there are fewer intermediates?
Fewer.
Fewer. Why is that?
Because it has to go through less reactions, so
Less reaction. So, you know, every time you do a like a chemical reaction, you carry out a chemical reaction, you don't get to produce 100% of the product, right? The product yield is always less than 100%. So let me show you this example here. Okay, if I have 2 intermediates, let's say A and B, compared to when I have A, B, C, and D, 4 intermediates. What is wrong with preparing the product using the second equation here? So you have, you can say route 1, route 2. Let's take the ideal scenario. Let's just assume that the percent yield of each step is 90%, which may sound like a lot, but can you try typing this on a calculator? When you do 90% 3 times, compared to when you do 90% 1, 2, 3, 4, 5 times, how much product do you think you will get at the end? Well, for the first one, we can do 90% to the power of 3 because you have it done 3 times. So 90% means 0.9. If you type this number on the calculator, compared to when you type 90% to the power of 5, okay, what is the answer? Let's find out. So 0.9 raised to the power of 3, so it will be 0.729, and 0.9 raised to the power of 5 will be, you see, the amount of product you get decreases exponentially. This is larger, okay, you have more products. This has fewer products. It's like doing a discount. Let's say you buy something, and then the merchant tells you, oh, there's now 90% discount, okay, only once. Compared to when they're telling you, after you take a 10% discount off the original price, we'll do a 10% discount 4 more times. Well, of course, you get a cheaper product at the end, this way. And this cheaper product in chemistry is equivalent to you having fewer products, which is bad. Okay, so there's good reason why in DSC they really want you to control the number of steps to within 3 steps. And if they ask you why, I want you to now know the answer. because there will be a lower product yield the more steps you take. So put this down. The more steps, write down in DSE, the number of steps in synthesis should not be greater than 3. Okay, so should be fewer than 3. Of course, if you can control it into just 1 step, even better. Yeah, because the more steps there are, the lower the final product yield. So the more steps there are, the lower the final product yield. Just remember this getting a discount on your goods, okay, analogy. Okay, so the lower the final product yield. Yeah, chemists, they tend to work in a pharmaceutical company, okay? And in pharmaceutical company, drugs are pretty expensive. I mean medicine, okay? The more step, let's say you are the chemist in charge in the pharmaceutical company, and you use the same amount of product, but then compared to you, another chemist who did 5 steps, okay, they get much less product. Okay, probably this person would be fired, okay? Yeah, because you're wasting. I mean, given the same resource, you produce less. Okay, of course you be fired. Okay. Now we have just one more. Okay, and for B, I want to share with you a tip. A lot of students, when they see this type of question involving especially the benzene ring, they panic. Okay, but let me tell you, you don't have to panic. Can you see that there are things that remain unchanged? Up to which part of the molecule remain unchanged in this process?
The benzene.
Not just the benzene, but also up to how many CH2?
The second.
Up to the second CH2 counted from the benzene ring. So therefore, just ignore it. Just make the whole thing out. Okay, this is a trick I want to teach you all. When you see something like this, just turn a blind eye to it because it won't matter. This group, CH2, 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 Br, it looks scary, I know. But because the reaction involves changes to only this part, the right-hand side part, this part remain unchanged on the left. So can you highlight it? This part remain unchanged. For the parts that remain unchanged, you can turn it into R. Okay? So that means this becomes RCH2Br. And this thing becomes RCONH2. Now it looks much better, in our opinion. Okay? So RCONH2. Yes. Yeah, you did what I plan on asking you to do. Identify the type of compound. What is the one on the left? Haloalkane. So write down haloalkane. And you should already be searching through your mental drawer of the organic synthesis pathway. Okay, you won't get that flow chart in the exam. It should be in your head. This on the right, you notice corn. Corn means amide. Is it a substituted or is it an unsubstituted or an N-substituted amide? Unsubstituted. Very confident. Okay, so this is an unsubstituted amide. Right. Where can we go from haloalkane? What can haloalkane turn into?
Alcohol or alkene?
Yeah, alcohol or alkene. But which of those things has a connection to the amide? Do you remember what?
Alcohol.
Yeah, it's not really alcohol, but carboxylic acid. And carboxylic acid, they are in turn related to alcohol, right?
Yeah.
Which class of alcohol?
First.
Primary. Okay, so you see, write down what your deduction were. You said halogen alkane can be turned into, or they cannot turn into alkenes. Do you remember? They cannot turn into alkenes because this reaction go only one way. You see, they cannot go back.
Oh.
This is why there's only one way. The only way is to this side, okay, to alcohol. You can use that to eliminate answers. Yeah, but there's nothing to eliminate this time. They can only become alcohol. Right, and then alkyl ends. Yeah, we can't seem to get any lead from here anymore. Now let's turn our attention to the right. What can form amide? What are the 2 parent compounds that are required to form amide? Carboxylic acid and don't remember, ammonia. Ammonia. So it's RCOOH, carboxylic acid, and ammonia. What's the formula of ammonia?
NH3.
NH3. Okay, actually, at this point, I want to remind you of something. There are two ways to go from carboxylic acid to amine. The first way
Turning
is to
esters.
no, not to turn it into ester. The first way is to add ammonia into it to form an ammonium salt, AlCOONH4+. And remember yesterday, I asked you all to do subtraction. Subtraction of what? We remove a water by heating. Can you subtract H2O from this? When you subtract H2O, what do you have left? And H2. This is exactly what you get, right? So this is the first pathway. Yeah, do subtraction. I really recommend that you write this down. Just write it as if it is math class, okay? You're doing subtraction. Yeah, and this is the first way to turn AlCOOH into amine. What is the second way? Is to use the halogenating agent, PCl3. Remember what can Cl substitute in this very big functional group? Does it substitute this entire COOH or just a part of it?
A part.
Part of it, which part?
OH.
OH, so what does it become?
COCl.
AlCOCl, okay? And then finally, you react ammonia with it. Yeah, and you will kick out an HCl in the process. Okay, right, yeah. This is a bit harder. Now, what we are doing is AlCOCl plus NH3 minus HCl. Okay, maybe write them in, maybe I will write them in such a way so that you can see it more clearly. When I add AlCOCl to NH3, and then I subtract ClH, which is HCl from that subsequently, how many atoms of each type are left?
RCO and H2.
Exactly. Okay, yeah, this is just a slightly more complicated math. Okay, so draw this box around these calculations here, and then you will see why you get this. So this is the product, AlCONH2. Try to find some way to have yourself make sense of those things. If not, it's impossible to remember, trust me. Okay, so you use this method. They are put down a heading here. 2 ways, okay, to make AlCONH2 from AlCOOH. What are the 2 ways? So pathway number 1, like you learned in Hess's law, so this is path 1, where you go this way. Path 2 is where you take a detour, okay, you do this, okay, like that. Okay, so this is path 2. Now, because the question has limited the number of steps, okay, but because they both have 2 steps, so it's up to you then. Yeah, so can you write this in here? Yeah, so show me what you can do to do this conversion. Let me copy this on the next page first. So we have, okay, so we have this. So the alcohol, what can you do to turn this into an alcohol?
OH minus.
Yes, OH minus, so can you draw it? So this, when you add OH minus to it, what will it become?
Then
What does the OH minus affect? Just the Br, right? It affects just the Br. So you have RCH2OH. Now, because we see that the lead is related to carboxylic acid. First of all, is this a primary, secondary, or tertiary alcohol? Let's try out to find out. What do you think it is? Primary. So write this down. This is a primary alcohol. A primary alcohol can be turned into a carboxylic acid how? By adding
oxidation agent.
Oxidizing agent. What is it?
Potassium
You give me the formula.
K2Cr2O7.
O7/H+, okay, and what's the condition if you want to get to the terminal immediately?
What do you mean the terminal?
Is it distillation or reflux? Reflux. Remember, reflux is like a fast track ticket, okay, to your destination. So you will do reflux and write down K2Cl2O7/H+. Now, I want to see if you remember what we need to do to convert an alcohol into an aldehyde and then a carboxylic acid. We are using 2 separate definitions of oxidation. The first definition of oxidation is the removal of
Water?
Hydrogen. Remember the two hydrogens that we removed?
Oh yeah.
Yeah, so can you remove that? We will go through the aldehyde station in the middle, yeah, which is R, C, double bond O, H, right? Yeah, so this is the aldehyde that we get in the middle process. What is the next oxidation definition?
Add oxygen.
Addition of oxygen. Where do we add it? Do we add it here? No, we add it
Yeah, that's
here. So can you add that? Okay, and show me the product on the right. LCOH.
Why
Yes.
we don't go straight to the alcohol?
Yeah, because we go straight to the alcohol, you don't have to show this.
Oh.
If it's just for you to
Oh,
like
revise.
yeah, know in the head. Oh, we need to go through an aldehyde. Okay, so this is an
They
aldehyde.
have the straight one. Go straight to carboxylic.
Yeah, and then you have a carboxylic acid. So I want you to show me the carboxylic acid now.
It first becomes
It's
aldehyde,
Al,
and then the aldehyde tries to
C,
the skin, and then when the
O,
aldehyde tries to the skin, it turns
OH.
into
Yes, LCOH. Now you are here. What is left? Once you get the carboxylic acid, what do you need to form an amine?
ammonia.
Ammonia, right? Ammonia. So we add ammonia. So ammonia. And finally you'll get the amide. Okay, so you have LCO and H2. Okay, so and in the process you remove an H2O in this process. So H2O. Right, so that's how you go from here to there. Yeah, and of course, in the exam you are not going to write out, okay, because they are giving you something, so you can just place this group on top of the hour, okay, like what I'm doing now. So watch, I'm going to place this here, here, here. It's like copy and paste, just paste it there, and that's it. Do you see that this is the exact same compound as this one? Yeah, so just ignore groups that you really don't have to pay attention to because they are there just to scare you, okay? Especially if they did not react. If they did not react, just make it any unknown you like. I like to make it out. If you like, you can make it X. Okay, just make it anything you like. Yeah. So the other questions, I want you to try it. Now that you are more confident, you should be more confident, okay, with the organic synthesis. Okay, yeah. There's no getting around this, but to really look at this page for half an hour. Just let it sink in. Yeah, because I can't think of another way to remember this other than to just treat it like a map. Okay, where you can go, okay, and how you can go from one place to the other. Okay, remember this. Even better, make your own. After you do the revision, make your own. Because the one I made, it just worked for me. But if you are the one who made it, and you remember where things go, before things can become, then that will be even better. Yeah. Now, let's take a look at some important organic compounds.
What is distillation?
Distillations for aldehyde.
So important
So like if you just want aldehyde,
organic
you think.
compounds.
But if you want the straight acid,
So the first one is S. Okay. Okay, perfect timing. So just make sure you finish this. Okay, I'll upload the answer to this onto Google Classroom later. And if you should start working on the what is that? I'm already making the paper for the 25th of October. Yeah, which would cover everything up to organic up to organic synthesis. So expect to see at least one question like this. Yeah, in the paper.
What about the remaining one? For the inorganic one?
Sorry?
For inorganic, what is the
It will
remaining?
cover everything up to this point.
Oh, la, 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 la.
Yeah, which means most of the compulsory past except patterns in the chemical world.
when is it going to be?
When? 25th. 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 Okay. Yeah, it will be a triple lesson like today. Yeah, so maybe it will last through the triple lesson.
Oh.
Yeah. Because if I make it too short, then maybe it cannot reflect what
An hour? Oh no!
Yeah, 1 hour and 30
Minutes.
1 hour and
35.
Yeah. Like a 10 or 15 minutes.
It's
So
1 or 2
make sure you bring
minutes.
make sure you bring a calculator and most important bring yourself. to
Okay.
us. Okay, like on the 23rd, 2 weeks from now.
As well.
Yeah.
As of right now.
You should be able to download the past paper from Google Classroom. I know some students told me that it says unsupported file type, yes, but then there's a 3 dots button on the top.
Oh,
Click
okay.
open it. You can open it in files and then you can unsave it.
Alright.
Okay? Yeah, try the question.
Not yet.
We can do the past paper. Upload the past paper.